Okay, yeah, so what we're going to be talking about here is we're going to be talking about what a function is. From here on out, and you might have heard this term somewhere before, but a function is something that shows up an awful lot in math. And a lot of people get really confused as to what a function is. And so in this section, we're going to kind of tell what a function is, and then from there, we're going to kind of go on and describe it in math terms. So today, we're kind of going to be talking about numbers and what a function is. And then from there, we're going to move on and talk about things that are a little bit more difficult. The first thing that we need to talk about when we're talking about a function is realize in any equation or in any situation that is mathematical that you're talking about a function, there are two different parts of any function that we need to talk about. And that is the input versus the output. Now, in most cases, when we see equations, particularly in math, our input is what number we are putting into a variable that exists in the problem. Okay, so in general, this isn't always the case. So don't always say that this is what it's going to be. But in general, an input would be something like x. Anytime I see an x and I replace x with a number, that means I am inputting some sort of number into what we call a function, okay? It's not always a function immediately, and we do have to realize that, and I'll talk about why that is in just a second, but realize that an input in general is like our x value, and that's kind of how we're going to treat it to start with, but that is our input. The output is once we put that number in, we get a number out. And that number that we get out, once we've simplified down whatever it is we're simplifying, and I know this is a little bit abstract, what we're talking about right now. Don't worry about it too much. But our output is generally the number we get out after we put our input in. A lot of times, the way that we see output, at least initially, is like a y. And so you've seen it written like this, like you might have seen an equation that is written y equals like 2x plus 3 or something like that. If I wanted to know, let's say for example, I wanted to just input a number for x, like x equals 2. If I do that, I would get y is equal to 2 times 2 plus 2. And then if I just used some math, 2 plus 2 is 4 plus 2 more is 6. You'll notice I would get y equals 6. X equals 2 was my input. Y equals 6, which is the number that I got that y is equal to once I input 2 in for x. Y equals 6 is my output. Okay, so the number I put in, input, the number I get out is the output. Now you might be saying, okay, we've done that before. That shouldn't be that big of a deal. Why are we talking about this? Well, it is a big deal if we put a number in, if we only get one number out when we put that number in, then we have what is known as a function. And there's a bunch of different ways to look at functions, okay? One way to look at functions is to say, okay, I've got these, and you can see them here, what is known as a mapping diagram. Okay, so I've got my input, and that's all of the numbers that are in this circle. Now you'll notice that as I put those numbers, these arrows, it's kind of like saying, okay, I took those numbers and I put them in, and this is the number that I got out. So in this case, my output for all three of those numbers is 6. Now this is where people get a little bit confused when they're looking at a function, because they look at that and they're like, well, 1, 3, and 5, when I put those numbers in, they all gave me 6. Whatever happened to the numbers, we don't know what happened to them. We don't need to know what happened to them. We do know that when we put them into whatever our function was, if it was a function, the number that we got out each time for each number was 6. This is an example of a function because for each input, so 1 there, 3 there, and 5 there, I got a specific output, only one output, not anymore. I just got one output for each of those numbers. Now, looking at the non-example, you'll notice that 0 here is pointed to 2 different numbers. That's not to say that that can't happen. In other words, if I take 0 and I plug it in one time, if I just throw it into my function and 2 pops out, or say it won't be a function, but if I throw it into like an equation or something, and 2 pops out, and then I throw 0 in a second time and 3 pops out, all that means is that that is not a function. It doesn't mean that you can't do it, it just means that it is not a function. And it only has to happen one time with any input versus output on a problem to say that we do not have a function. So all of these, even though 5 is only pointed to 4 and 10 is also pointed to 4, not a big deal, but the fact that 0 is pointed to both 2 and 3, which means I put those numbers in and the number I got out the first time was 2, the number I got out the second time was 3, that can't happen, so we would not call that a function. Okay? Now, another way that we can look at functions is if we look at a graph. Anytime I look at a graph, what I look for is, it's a little bit more difficult to see if every input has one specific output. The x values in general run right to left and the y values run up and down, but the way that I tell whether or not something is a function is I use what is known as the vertical line test. And all the vertical line test is doing is it's doing the same thing that we were doing on our mapping diagram. It's just doing it in a way that makes a little bit more sense visually. The vertical line test says this: if there is a place anywhere on the graph that I can draw a vertical line, straight up and down is vertical, and it touches the graph more than once, in other words, not the x and y axis, we don't include those, but besides those, this v function right here that we're looking at, if it only touches that once, then yes, we do have a function. If anywhere on the graph, not the entire thing, but anywhere on the graph, it touches more than once, like right here, for example, if I draw a vertical line right there, or over here, in either of those places, you'll notice that my line that I drew straight up and down touches the graph 2 times. And it's 2 or more. If it touches 2 or more times, then no, we are not looking at a function. So that's how you tell with a graph. You just look at the graph and you say, oh, can I draw a vertical line and have it only touch once? If it does, anywhere on the graph. If it touches more than once, it's not a function. Otherwise, we can say that it is. Tables are a little bit easier because all we're doing is it's almost like a mapping diagram, but instead of drawing arrows, they're saying, okay, for this x value, -1, my y value is -4. For 2, it's 8. For 5, it's 20. As long as the x values do not get a different y value, in other words, they only get one y value every time, then we have, yes, that is a function. Whereas over here, you'll notice I've got 1 is mapped to 6, that's what the table is saying, 2 is mapped to 5, and then 4 gets assigned to 4 and to 3. Now again, that's not to say that that can't happen, because that can happen in certain mathematical situations. It's just in this case, because we're looking to see whether or not this is a function, we say no. That is not a function because 4 is being assigned to 2 different numbers. On equations, generally what you look for is to see that y is all by itself. In other words, I just have y, or if y is only being raised to an even power in the problem. It's entirely possible that you have an equation that has y's in it that are raised to odd power. So y to an odd power, will give you a function. Now if there is no y, like in this case, no y, or y is being raised to an even power, if that's the case, then we do not have a function. Again, it's not to say that you can't do that, it's just that does not represent a function. Because I'm not just going to get one y value out when I plug in a specific x value. Okay? So the way that we write a function, we've talked about this already, the way that we write a function is we have y is, to start off with, this represents a function. Like let's say I had y equals x plus 3. Okay? Now, because I know that this is a function, because y is all by itself, it's not being raised to an even power, and there is a y in the problem, I can say that this is a function. If that's the case, all we do, and this isn't a big deal, but all we do to let people know that we know that it is a function is instead of saying y equals x plus 3, we say f of x is equal to x plus 3. All that's saying is I know I'm only going to get one specific y value out. F of x still means y. That's the way we say that, f of x, not f parentheses x, and it's not f times x. The way that we say that is f of x. And all that means is we know for a fact that that is going to be a function. And so instead of saying y equals that, I say f of x, meaning this is a function of x. They mean the same thing. Don't get confused. In fact, if I had a different one, let's say I had w equals 4t minus 7. That is a function because I would put numbers in for t and I would get specific w values out. So what I could say there is I could say, instead of saying w, I could say w of t equals 4t minus 7. That changes nothing at all. It still means the same thing. It's just saying I know that if I plug in a t value, I'm only going to get one y value out. So I look at these examples to determine which are and are not functions. The first one, you'll notice it is a vertical line. Well, a vertical line most definitely does not pass the vertical line test, so that is not a function. Down here, I've got a mapping example. I've got my inputs here. Generally, inputs are on the left because they are pointing towards the outputs. That's why the arrows are pointing there. All of those numbers are only pointing to one specific output. Since that is the case, this is a function. I look here. One thing that I can say right away is I see f of x. By seeing f of x, I know for a fact that is a function. And on the last one, you'll notice it does have a y. It's an equation. It does have a y, but y is being raised to an even power. Since y is being raised to an even power, I know already that is not a function. So that is just basic terms when it comes to knowing what a function is. The main thing that we should probably take away from this is when I see f of x, I know it looks scary, but all that's saying is that is a y value, and I know I'm only going to get one y value out, and we'll kind of move from there. There's one other way to use functions that we will talk about a little bit later. Not difficult, but I just wanted you to know there's one other way that helps us understand what is going on with a function that we will get to. Again, if you have any questions, please ask your teacher. And other than that, good luck.